Hello and welcome to this edition of Technical Session on Standards covering the field of electrical transformers. I am Asit Kumar Maharana and I will take you through this session. As we know, these sessions are meant to bridge the gap between what we study on electrical transformers in our curriculum and what is needed in the actual field application conditions. It is imperative to note that what we study in our curriculum is essential to build a strong foundation of our basic concepts on electrical transformers. However, the actual field conditions require more specificity in terms of transformers quality, performance and reliability aspects which are addressed in standards. The basic principles of transformers that we have studied so far are: it is an electromagnetic device which transfers electrical energy from one circuit to another circuit through the medium of magnetic field without any change in the frequency. We have a primary winding or a set of windings on the primary side as well as a set of windings on the secondary side wound over a core. Within the framework of the academic curriculum, what we have learnt about transformers are: they are single phase, three phase and auto transformer configuration, basic constructional features, phasor diagram, equivalent circuit, transformer connection, voltage regulation, parallel operation, eddy current as well as hysteresis loss, all day efficiency, open circuit and short circuit test, essentially for determination of circuit parameters and not as performance assessment criteria. You must have learnt about the basics of transformer design, cooling arrangement, terminal markings and rating plate details, installation and commissioning, and the basics of routine test and type test. Routine tests are the tests that are performed on the transformer during its manufacture or immediately after it to ascertain its conformity to the specified requirements, while type tests are the tests carried out for validating design compliance. So, these are the topics that are essentially covered during the academic discourse. However, from standardization perspective, it is very important that everyone who applies the standard or comprehends its requirement have a uniform understanding of what is specified. To facilitate a uniform understanding on different types of transformers and what they mean, definitions are specified in the Indian standard IS 1885 part 38. It not only specifies what a power transformer or an auto transformer is, but also the different types of configuration such as core type and cell type, dry type, sealed type, etc. You can refer to IS 1885 part 38 for more details on definitions. The classification of transformers are based on different aspects, some of which you are familiar with. However, the classification of transformers covered under Indian standard are a little broader, encompassing all types and varieties. These classifications are based on core design, material of the core either CRG or amorphous, application, insulating medium whether mineral oil or ester filled or gas filled, etc. and likewise. Based on the classifications, there are different series and different Indian standards for the respective category of transformers. While the Indian standard series 2026 essentially covers the power transformers, 1180 covers the distribution transformers and 16227 series covers the instrument transformers like voltage and current transformers. There are other Indian standards for welding transformers, arc furnace transformers, etc. Let us discuss on the quality aspects of transformers with an attempt to capture user expectations. Every product has a set of user expectations. In case of transformers, the users are the power utilities and distribution companies. From their viewpoint, the expectations are broadly classified into four categories: reliability of operation, safety in operation, interoperability and efficiency. Let us dive deeper into each one of them. What do we understand by reliability in transformer operation? It is expected that the transformer has the ability to withstand operational disturbances while maintaining continuity of electricity supply and is able to deliver load as per the rating of the transformer. Similarly, when we say safety in operation of transformer, we expect that it should be safe to operate the transformer without abnormal temperature rise, leakage, faults that can cause safety hazards under normal operation conditions. Interoperability is one of the fundamental goals achieved through standardization. In a practical use case scenario, in the event of a fault in a transformer, it should be possible to replace the faulty one with a healthy one, which is possible only when interoperability is ensured. Even for parallel operation also, this is a desirable feature. In the case of transformer, vector group, voltage, voltage ratio, standard fittings and accessories etc. facilitate interoperability of transformers. Transformers should have minimum operational losses as they are under continuous operation 24/7 365 days. Therefore, load losses at different levels of loading as well as no load losses are important considerations from a user's perspective. How do Indian standards address these user expectations? Standards through specified requirements and validation tests provide guidance on meeting the user expectations. Let us understand by analyzing one of the Indian standards on transformers, IS 1180 Part 1, which covers mineral oil immersed distribution transformers. Other Indian standards also have similar or slightly modified requirements to address these user expectations. Provisions under clause 9.1 and 20.1 of IS 1180 Part 1 provide for materials and components respectively to be used in the manufacture of distribution transformers. Validation of reliability is done through specific tests such as induced overvoltage withstand test, separate source voltage withstand test, lightning impulse test, permissible flux density test specified in the standard. Similarly, to address safety aspects in transformers, the standard prescribes permissible temperature rise under clause 6.10, 7.10 and 8.10, limits to rise in pressure inside the tank as well as oil leakage test. Interoperability aspect is facilitated by IS 1180 Part 1 as it specifies the standard ratings of the transformers, dimension of bushing, minimum clearances in air, winding connection and phase displacement or the vector group etc. Even the rating plate is also standardized to contain all the vital technical details of the transformer. Energy efficiency aspects are addressed in the standard through specification of no load losses and load losses at 50% and 100% loading for different type and voltage class of transformers. Based on these losses, the transformers are characterized into 5 different energy efficiency levels from level 1 to level 5 based on the loss. Now, we have seen how different user expectations are addressed in the standard through an example. Let us see through some of the tests that are prescribed in the standard to ensure quality and performance of the transformers. The tests are more advanced than the fundamental ones that are taught in the classrooms. Through a few examples, you would be able to appreciate the significance and need of these tests to address the field requirements for transformers. You must have studied about short circuit test, the open circuit test, the voltage ratio test, the winding resistance measurement test etc. in your curriculum. However, in the actual field condition, we need to ensure that the transformer performs reliably and safely, withstanding many disturbances but has the ability to provide continuity of electricity supply. In IS 1180 Part 1, these tests are divided into 3 categories. They are routine tests, type tests and special tests. One can find that there are many tests which go beyond what we study in our academics, such as lightning impulse test, temperature rise test, overfluxing test for core, to name a few. Even the short circuit test carried out on a transformer as per the standard has a different purpose and a different methodology from what we study in our syllabus. Let us see a few of these tests as specified in the standard IS 1180 Part 1 and understand their significance. The most critical factor for reliable operation of a transformer is how the dielectric stress on installation is handled by the material used. As we know, there are essentially 3 types of insulation in a transformer: interturn insulation, insulation between winding and core, insulation between windings of different phases. Lightning impulse test is an important test performed on a transformer. As we know, lightning is a common phenomenon which impacts the transmission lines because of their tall height. The lightning strike on the line conductor causes impulse voltage which reaches the terminal equipment such as transformer through the transmission line. This causes the transformer to experience lightning impulse voltages. The transformer should be able to withstand this lightning impulse voltage when it is under operation. To make an assessment of the ability of a transformer to withstand lightning impulse voltage, this test is performed. The lightning impulse test uses natural lightning like voltages to assess transformer insulation, identifying weaknesses that could cause a failure. Since it is very difficult to predict the actual wave shape of a lightning disturbance, from the data compiled about natural lightning, it is concluded that natural lightning can be represented by 3 basic wave shapes: full wave, chop wave and front of a wave. The lightning impulse test is performed as per the test method prescribed in IS 2026 part 3 and the waveforms on oscillogram are examined for any abnormality. Impulse voltage of different magnitude and shapes are applied to the transformer in the sequence prescribed in the standard. Let us see one more test, that is short circuit test. The short circuit test is prescribed in the standard is different from what we study in our textbook. We have learned that short circuit test is performed for determination of circuit parameters. However, practical short circuit test is performed to make an assessment of the ability of a transformer to withstand axial and radial mechanical stress developed during a short circuit in the system. In a high voltage system, the most probable type of short circuit is a single line to ground flashover. To perform the test, the voltage is applied on the high voltage side while the low voltage side is short circuited. Once the test condition is established, single line to ground fault is introduced on each phase 3 times. The voltage and current waveforms are monitored and recorded. Routine tests before and after short circuit tests are performed to analyze any variation in the reactance values. The transformer winding and core are untanked and examined to locate any damages. In these two foregoing examples, we have seen that the method to perform tests are also standardized and defined in the standards. There are certain advantages of standardized test methods. They make testing uniform, ensure repeatability and reproducibility of test results, uniformity in reporting of the test results and their easy acceptability. Academic curriculum is meant for understanding fundamentals and are more focused on development of analytical thinking on key concepts. For development of professional ability, many practical considerations need to be taken care of. Standards can be the enabler to bridge this gap. One can use the Know Your Standard style on the BIS Care app to access Indian standards on various topics which contain essential learning concepts to augment your technical learning. You can use the keyword search feature to search for Indian standards on any subject. I am leaving you with a list of Indian standards related to transformers for your convenience. If you have any queries, please write to us. We will be glad to answer them. Thank you and hope you enjoyed the session. See you again.